Hey, welcome to part 3. Part 2 has been uploaded in the members area. Become a cloud kernel or cloud ninja. If you have not yet subscribed, this channel will help you with AWS, Azure Cloud, and Google Cloud certifications for a very small premium. Gain access to so many important questions. Become a cloud kernel or cloud ninja member. There are 1,000+ videos on this channel, lots of playlists for various levels of certification, entry level, intermediate, and advanced on AWS, Azure, and Google Cloud. Let us look at the question. There is a company, okay, and they have an application. What it does is it ingests incoming message. Now, looking at this question, first of all, you have to understand what is this. This is about messaging systems, middleware kind of systems. Like it can be Kinesis, it can be uh, not SNS particularly, but it can be SQS or whatever. So we got a gist of it. Now they are telling, see, there is a producer, there is a consumer. So uh, their messages are coming and it is getting consumed. So number of messages vary drastically. Okay. So it increases to 10 or 100K every second. Now the company is saying, I want to decouple the solution. So many times, see what happens, a producer sends one record, you want the consumer to receive one record so that it gets empty. The queue gets empty. Now, if the queue is not getting empty and immediately so many messages are coming, so you want to decouple the solution so that messages will be there in the queue. Producer may send 100 records, uh, but consumer may consume only 10. They will consume when they want. So that is called solution decoupling. Okay, how would you do this? See, one thing I'll tell you, whenever you look at the requirement and people are talking about decouple, first thing you uh, think about SQS. This is the main solution used for decoupling. Okay, in this case, they're saying we will use SNS topic and SQS subscriptions, and consumer applications will process messages from the queue. Let me explain this. We have a justification here. So SNS topic for decoupling, it is a pub sub service. Okay, so messages go to SNS topic. This will decouple the ingestion application from consumer. Like producer and consumer gets decoupled. And the next thing you do is you use SQS subscription for parallel processing. So multiple SQS can subscribe to the same SNS topic. That is not a problem. And it allows parallel processing of messages. SQS is very reliable and scalable. Option D is our answer. Option D. Now, why A, B, and C are wrong? Why? See, A is wrong, B is wrong, and C is wrong. Why? See, Kinesis data analytics. It is not a decoupling solution. That is why A is wrong. Now, auto scaling group. So it can improve throughput, but what about decoupling? It does not serve the decoupling requirement. So this is wrong. Now, C, DynamoDB and Lambda. See, you are now increasing complexity. You are making things very complex. And not only complex, it is not adding a value. It is creating bottleneck. Okay. Plus you are using DynamoDB, which will increase your latency. Latency should be reduced. That means it should be fast. Moment you type a website name, it should appear very fast. So option D in this case, like I told, if you don't want to understand so many things, The moment you see decouple solution, just think of SQS. Simple. See, company, they have a distributed application. Now they are saying, boss, let us move to AWS. Like everything, everybody wants to go on cloud. So, uh, this application, what is the nature of this application? It has variable workloads. Sometimes it takes more time, sometimes less time. Okay. And in today's world, before migration, what is the setup? Boss, what is the setup? They have one primary server and it talks to multiple compute nodes. That is today's setup. Now, company is saying, boss, I am now moving to AWS. You, as a solution architect, please ensure you get maximum resiliency. That means downtime should not be there or minimized first. And they are telling, boss, please make it scalable. Today, if there are 100 users, tomorrow there are 1 million users, it should work like butter on the, like a knife on the butter. Now, you as a solution architect has to design this. What will you do? What will you do? See, here you have to use SQS as a destination for the jobs. SQS is required here. Okay. Uh, why? Why? Option B looks correct in this case. I'll explain why. It is telling I'll use SQS for job query. We all know it is reliable messaging service and so on. So what it will ensure, no jobs are lost. If compute node fails, there are no jobs which are lost. So that takes care of resiliency. It is reliable. Now what about scaling? See, EC2 auto scaling. See, EC2 has auto scaling features. We all know. So we will tell auto scaling. We have to base on the size of SQS queue. If SQS queue is small, we will have in auto scaling say two EC2 instances. If SQS queue is big, we will tell auto scaling boss create 20 EC2 instances. That way, the size of SQS queue decides your scalability. So that way, the number of compute nodes will increase or decrease. Okay, this is good setup. And what it means is your application can scale up to handle peak loads and scale down during low periods. So your resource utilization is managed properly. If you manage your resources properly, you will not need too much resources every time. So you will save money. I hope you understood this. The option A, that's telling was let us use scheduled scaling. If you see the question, there is no clarity that when the peak loads come. Like sometimes my jobs will run 9 to 12 p.m. So I want I can use schedule scaling. I can scale 100 EC2 instances and manage my load that time. But I don't know when I want. So how can I use schedule? I cannot schedule. I don't know which time this peak load will come. Now C says we will use Cloud Trail and load primary server. The Cloud Trail is a very different service for logging and audit service. It is not a message queue service. D says Event Bridge. The Event Bridge is for event-driven processing. It is not efficient as SQS queue, first of all. And the compute node load as scaling trigger can lead to delays in scale up. So this solution will not work. In this case, B is our answer because it makes it resilient and scalable. See, there is a company, okay, and they are running SMB file server in its data center. So when you think of SMB, think of Microsoft Windows. It's a protocol for Windows, not for Linux. So the file server stores large files, and now They want to put it in S3. What is the what do you know about the storage mechanism? How do they do it currently? They are telling that very frequently accessed files for first few days are created first, and after 7 days they are rarely accessed. So this we know that files are used for the first few days. After 7 days, hardly people are using it, and total data size is increasing and is close to company's total storage capacity. That means company no longer on premises, they don't have much storage. That is the reason they are moving to S3. So what you have to do is you have to design a solution, storage solution first. Okay, and you should not lose any data first. No, don't lose any data. Second is you should provide a lifecycle management to avoid future storage issues. Like that, currently they are falling short of storage. In future, in S3 also that should not repeat. They should never fall short of storage. So what will they use in this case? That is the question. See, our answer in this case is B. We create file gateway, S3 file gateway. So you don't have to add more storage on premises, and you can use lifecycle policy. So when the file becomes old, you move it to Glacier after 7 days. So file gateway, it provides seamless integration between on-premises and S3, especially in your SMB file server setup. That is one. Okay. And S3, we know it has unlimited storage capacity. So running out of storage is out of question. The second thing is lifecycle policy. You have to transition infrequent access files to Glacier because Glacier provides low storage cost. It is cheaper than standard S3. So if people are not using those files, why will you keep in hot zone? You keep it in freezer like chicken or meat. You got it. You have to store it for a long term. So you put it in the freezer like same like that here. So option A is wrong. C is wrong because FSX for Windows, it's for Linux actually. I don't know. See, data sync can copy data to S3, but it will not provide same level of integration like file gateway. It requires manual intervention to copy the data. For FSX for Windows, the solution would increase storage cost as it involves fully managing file system. So it is not cost effective for storing infrequently accessed data. See, this data you are not going to access like a hot zone data. So why do you want to spend so much of money? And installing utility on each computer, this approach is complex to implement and manage, and it requires users to change their workflow. So this is absolutely crap. This is not required. So our answer is option B in this case. Option B, using file gateway, we can ensure that on premises, even if you are getting short of storage, don't worry, move your data to S3 and lifecycle policy will ensure that you save storage cost for infrequently accessed data. So this brings us to the end of part 3. Part 2 has lot of questions. We have given a lot of explanations for different options and answers. Please access it it's for members, Cloud Kernel and Cloud Ninja members can access it. So remember, this channel is all about helping you with certifications. We have 1,000+ videos on different types of certifications like AWS, Azure, Google Cloud, and entry, intermediate, and advanced certifications. See you in the next part.